Good day and welcome to another edition of Streakwave Webinars. Streakwave Webinars offers information and education on products and technology enlightenment. We're here to give you information that you need for your business. Today we're pleased to be presenting Cambium ePMP for North America. This line from Cambium offers a wide breadth of features, options, and flexibility. It's a cost-effective, dynamic, and feature-rich product line featuring such options as GPS sync, connectorization, and integrated options. It has a highly refined proprietary operating environment and can operate in the Wi-Fi environment, and ePMP line offers something for every project. My name is Richard Bernhardt. I'm the Senior Director of Marketing and Communications for Streakwave Wireless. Streakwave is a value-added global distributor, and we are actually a distributor for Cambium Network. So if you see or hear any products that you're interested in on this webinar, please let us know. You can reach us directly at 888-604-5234 or come to the Streakwave website at streakwave.com. For any specific products or questions, give us a call. I'm very pleased to have with me today Sakid Ahmed. Sakid is a longtime wireless industry person with over 20 years experience. He joined Cambium at its beginning and is now the Senior Director of Engineering. Sakid will be our presenter today. Throughout the presentation, you will be hearing about products and technology. If you have questions on any of these, you can type them into the digital questions section or send them along to us and we'll be glad to answer them. If you have direct questions, please contact Streakwave. Welcome, Sakid, and let's get on with the presentation.
Good morning, and welcome to the Cambium Network's ePMP Wireless Broadband webinar. We're going to go through some product overview of the ePMP product line, along with some key aspects of the ePMP product, features specifically, differentiation in terms of the ePMP product line, and focus a little bit on how ePMP as a solution for your wireless broadband needs can provide the benefit you're looking for in terms of application offerings, better frequency reviews, and things like that. First and foremost, a quick overview of the Cambium Networks, who is delivering the ePMP product today. Cambium Networks evolved from the Canopy point-to-multipoint product line, as well as Orthogon systems. These are well-known brands at one point that were part of the Motorola solutions. Canopy being a very reliable point-to-multipoint product that has served the industry for many years. Orthogon systems delivering a point-to-point solution that was also a very reliable and well-known product platform. The combination of these two out of Motorola solution evolved as Cambium Networks, which is today a very fast-moving development engineering company with lots of products, lots of excitement in the technology that we're offering in the marketplace, and that's what has arrived from Motorola Solutions. A little overview on the Cambium product category, just to help people understand what are the primary offerings. On the left side is point-to-multipoint. That is the core nature of the business and product offering. In this case, we are referring to outdoor access point base stations connecting to CPEs at residential homes, enterprise offices, schools, utilities for that matter, and providing wireless broadband connectivity. And of course, where there is a base station or access point, there's going to be a need for backhaul. There are lots of numerous choices in the backhaul front, and we offer various of those in wireless form, whether it's licensed, unlicensed, or microwave backhaul point-to-point solutions. Let me get into a little bit of the ePMP product line, but specifically let's start by talking about some of the problems that we think that the wireless service providers or other businesses using unlicensed broadband faces. I have some images and some phrases here. I'm going to touch on them a little bit, but first and foremost, we talk a lot about precious spectrum. This has to do with the fact that we are operating in unlicensed 5 gigahertz primarily, or 2.4, in which case the spectrum is very key, and being able to manage interference and reusing channels that you find free is a key aspect. And while you're in operating in unlicensed spectrum, achieving higher throughput with what you have and being able to constantly serve the ever-growing need of our consumers is key. Capacity, being able to serve multiple sub-CPEs to an access point when you have density and require increased number of CPEs is also very key. And then last but not least, the idea of increasing your ARPU through offering applications. And the fundamental message there is that the users are no longer just doing web surfing. There's Netflix, there's voice over IP, there's applications such as security cameras, enterprise connectivity, and all of these applications require some level of quality of service, reliability in the connection. And that's something that we as equipment manufacturers and you as service providers look to solve. My next slide is actually a sample picture from a Cambium Network's test location that shows the problem of crowded spectrum in 5 gigahertz. This is, I've seen many worse, where the spectrum is crowded in the entire 5.2 to 5.7 band. So therefore, the message here is that the channels you do find every now and then that are clean and you're trying to operate on, it's precious to you. You want to be able to maximize the use of that spectrum or channel, whether it's a 20 megahertz slot or a 40 megahertz, or for that matter, in some cases you may back down to a 10 megahertz or 5 megahertz. That spectrum is precious. Because we're working in unlicensed spectrum, everybody's on it, and therefore being able to maximize that channel is key. And then let's just go back to the last slide real quick. So the situation with unlicensed spectrum, I kind of touched on this, but too many operators are using the same spectrum. A common theme that we find out by talking to customers or even from our own field experience is there is often a tendency to say, if I can get more power, I can put a bigger dish, I will outride the interference, and I will also be the winner in this fight for being able to offer service. There's also a good amount of equipment out there that you often encounter where the shielding on the transmitter or the receiver, or in general protection, is not sufficient. The result of that is that these pieces of equipment out there will create additional interference and noise to the already existing problem of interference in unlicensed spectrum. So what do we do today? We look for the next clean channel. Spectrum analysis becomes a second nature to operators who are trying to find the next clean channel. We buy extra hardware to protect the towers. We try to shield one access point from another access point on the same tower facing away. Then we try to find lots of guard band and channel separation to avoid this interference. The fundamental conclusion there is, in the world of interference, a biggest source of interference is going to come from your own equipment. While outside interference, other operators, other equipment is not in your control, solving your own self-interference is fully in your control, and that does go a long way in offering a more efficient and reliable system. A little bit on the fundamentals of this primary self-interference, and then we will get into the product-specific differentiation and why ePMP makes sense. The primary self-interference that we talk about a lot here is the fact that access points that are transmitting and receiving are doing so in an unsynchronized fashion. The green and the orange in this little animation represents transmitting and receive cycles, or let's just say talking and listening. And when multiple access points on a tower are talking and listening at various times, then they will overlap their talking and listening periods on top of each other. This is one of the fundamental reasons why interference, i.e. self-interference, becomes an issue when your own access points are stepping on each other as they're trying to transmit or receive. ePMP. It is a platform today, and I will go through the solution overview and some of the hardware, but ePMP is a platform that essentially solves this self-interference problem. And the uniqueness of ePMP is that today in this market, it is the only platform at this price range that solves successfully self-interference problems. In a nutshell, there are various aspects to ePMP, which we will touch on here in a second. There are various aspects to ePMP that essentially puts the power of a $3,000, $5,000 base station in a $500 access point. And that is the fundamental message of ePMP. Examples of what those things are. This is the one platform where GPS synchronization is a functioning solution, and GPS synchronization is one of the foundations of offering the platform and solving the self-interference problem. Along with GPS synchronization, ePMP system will offer what we call a TDD frame structure, a fixed uplink downlink frame structure, which is one of the options. But with that, along with GPS synchronization, we provide a solution for self-interference. What does it give you? You're now able to use the same two frequencies on a tower with only 5 megahertz of guard band. In the past, you may have had to put 20 megahertz of guard band or 10 megahertz of guard band, or put metal shields behind the APs in order to achieve frequency reuse. So the fundamental message here is frequency reuse is what I'm giving you with ePMP at a very competitive price range. And the frequency reuse is coming from concepts of TDD, concepts of synchronization, i.e. GPS synchronization. And ultimately, you can now start building a network of ePMP access points in a wide geographic area using, let's say, 4 frequencies in a ABCD deployment scenario. And I have a picture for that coming up in a minute that will make sense. The last 2 bullet items that I will touch on this slide is that the fact that on ePMP, we have the concept of transmit power control, which actually is a very advanced concept that is used in LTE WiMAX system. In fact, all 3G systems have that. The idea is that the base station is always in charge and will tell a CPE what type of transmit power it has to transmit in. As I mentioned earlier, there can be tendencies where we achieve or shoot for higher power thinking that is the best way to solve my interference problem. But fundamentally, too much power can actually cause further self-interference. Therefore, having a system, and when I refer to a system here, I'm talking the base stations and CPEs across the entire geographic area, to be synchronized and have transmit power control where each SM is trying to, each CPE is trying to arrive at the base station at the same uplink target receive level is very key. This creates sort of a harmonious system and reduces self-interference. The last part on the ePMP side is the actual front-to-back ratio, which is key on the sector antennas themselves. This is another tool in the arsenal of providing a self-interference reducing solution. Higher front-to-back ratio on the antennas will mean that less energy will go from the front AP to the back AP. The concept of TDD, where the downlink, uplink, i.e. talking, listening, is synchronized across multiple base stations, multiple APs, is shown here as all the APs 1 to 6 is transmitting at the same time. Therefore, their green and the receive cycle are all synchronized. And while GPS sync is mentioned, GPS sync essentially is the source. It's the how. the benefit you're getting out of all of this is frequency reuse. A summary of 3 key components that ePMP offers that gives you this synchronized frequency reuse system. First and foremost is the concept of this TDD MAC, where you're seeing this downlink, uplink being synchronized across base stations. This avoids the collision collapse, which is as an earlier animation showed, where APs are talking, listening out of synchronization and therefore stepping on each other. Number 2 is the automatic SM transmit power control, where each SM is now being told by the access point on what their transmit power should be. And then last but not least is the antenna front to back isolation. This image gives you an idea of how this is working. As you can see that subscriber module Y shooting too strong of a power and overpassing access point Y and impacting access point X. This is something that comes into play when you are trying to do frequency reuse, and therefore having SM power control is very key. In the secondary type of self-interference is the antennas front to back and how that plays a role. Every antenna's job is to amplify in the front, but there's always going to be some energy that is amplified in the back. Being able to control that ratio so that it's low is key to making sure that self-interference in a synchronized system works as efficiently as possible. A quick image of the GPS sync, a visual representation of a tower with AB, 2 channels that are back-to-back, 360-degree coverage. Then you go over to a 4-channel network and you can start building a much bigger geographic area with ABCD 4-channel usage. The next slide in a picture, it shows a very dense neighborhood, but the message here we want to talk about is the scalability. We have a message that ePMP access point supports up to 120 SMs. Realistically, given today's data usage and the demand of customers, oversubscription plays a big role. Bandwidth packages plays a big role. For a North America marketplace, I would say 65, 70 subscribers are something that I've seen people get to and still be able to serve the bandwidth needed by end customers. But the fundamental message here is that the ePMP system from the ground up, along with the GPS sync, along with the power control, has a MAC system. And when I refer to MAC, there's the PHY and then the MAC layer. In the MAC layer, we designed it so that as you add CPEs to an access point, the performance does not degrade. This has been a common theme in the marketplace where 20, 30 subscribers on some systems will start degrading the access point's performance. ePMP does not do that. How do we do that? We have a access point that is always in control, manages every transmission and receive cycles in the entire sector. The timing where a subscriber or a CPE transmits at a certain time, then it's turned to listen, and how we serve multiple subscribers, all of that is very tightly controlled. We have the concept of a air fairness scheduling, where we do not allow a particular CPE that's in poor RF condition to drag down the entire sector throughput. And then last but not least, an adaptive modulation mechanism, which essentially goes up and down based on interference. We react to interference with the thought of keeping throughput as the highest consideration. And the ability to move the adaptive modulation system preemptively as opposed to always reacting is key to making a very highly reliable and high throughput system in the presence of interference. A little bit deeper technical background on this MAC concept we talk about. The message here that I spoke about, where we said that 20 to 30 subscribers and a system starts degrading, really has to go back to what is known commonly as a polling protocol in a lot of systems out there. Polling protocols are fine to some extent, but when you try to add a lot of CPEs to an access point, polling protocols do fall apart to some degree. And fundamentally, the polling protocol that we see commonly represents a one-to-one relationship between a base station and a subscriber. So you'll often see that a base station to a CPE performance from a throughput latency perspective is very, very good, but as you start increasing CPEs onto that access point, that performance starts degrading. And this becomes even more apparent if one particular CPE among the 15 or the 20 happens to be suffering from interference. And this all has to go back to the way the acknowledgments are coming back and forth, the handshaking and the packet transmission or a negative acknowledgement. All this is happening in a more or less one-to-one relationship. And this creates a very fast, efficient system for a very small number of CPEs. But however, this starts falling apart as you increase the number of subscribers. The ePMP-MAC protocol efficiency, if you notice the difference in the picture, you'll see, once again, if I go back real quick, is you have downlink for subscriber / CPE1, CPE5, CPE3. You have acknowledgments, propagation delay, time it takes for packets to come in and out. And then if you look at an ePMP system, you start noticing that we have a fixed downlink period, fixed uplink period, and time in between for the turnaround of the propagation delay to the furthest subscriber. And all this is time bound within a 5 millisecond frame so that everybody is doing what they're supposed to do at precise times. And the most important thing out of all of this is that at the beginning of the downlink frame or beginning of any frame, we have the concept of a GPF, which is a group poll frame. And this is the broadcast message which advertises and tells every subscriber who is about to get downlink traffic, who is about to is allowed to send uplink traffic. So consider the GPF a bit like a Google map that's laying out the lay of the land in terms of who is communicating when. So this is at a high level, but what the fundamental message we are providing on ePMP is we have built a MAC layer, a protocol that is extremely advanced and efficient in terms of how it deals with scheduling and allocation of subscribers in the uplink and downlink. And this is one of the more complex problems one has to solve in a wireless system, and we have done that with the ePMP solution. Quick picture of a lab environment. Granted, it is a lab. I will go right past this, but this is 120 SMs in an access point. The need for speed. This is one of the other problems as the requirements come up and there's more Netflix and data usage. What do we do with that? ePMP, the fundamental message here is we are offering consistent latency and higher throughput in the presence of interference, and then what I just spoke about, higher real-world throughput as the number of SMs are increased. We fundamentally have a PMP, point-to-multipoint, and a PTP mode of operation. So these are 3 different modes where with GPS sync you can do frequency reuse. It's highly scalable. We offer a flexible mode where you're no longer doing GPS sync, but you're still scalable and get lower latency. And then a point-to-point mode where we offer the lowest latency but not GPS sync. Speeding up a little bit, we talked about the air fairness adaptive scheduler. This is the concept where a bad subscriber in poor condition is not taking down the entire sector's performance. And in this case, the differentiation is the fact that we are allocating time, equal time to all the subscriber, as opposed to allocating time based on bandwidth needs, which is typically what causes a poor subscriber to suffer or cause problems for the entire sector. Interference optimized rate adapt algorithm. lot of R&D effort has gone in to tweak this in order to make sure things like TCP performance, latency stays reliable as you scale. But we won't get into this too much other than to say that we have put in a lot of time in one of the most important aspects of a wireless system is the interference and the reaction of the rate adapt algorithm. Applications. We talk a lot about service providers, but at the end of the day, this is a very, very suitable solution for numerous things from voice over IP to surveillance, Wi-Fi backhaul, smart agriculture, IPTV, enterprise connectivity, to name a few. VoIP and ePMP. We do think we have the best-in-class VoIP performance. We have over-the-air quality of service, which is very, very key for any unlicensed spectrum usage. We have automatic prioritization, so if you enable this, VoIP packets are automatically detected and prioritized to the front of the queue. And then last but not least, the adaptive modulation mechanism that I spoke about a lot, that is dynamic, and it does do some balancing between retries and minimizing jitter for VoIP packets when it detects voice. So I say with high confidence and with lots of field data that voice over IP on ePMP will be one of the best performing voice over IP systems in interference or without interference. Bit on quality of service. This is where we have the voice priority, high priority, low priority channels. You have your standard layer 2 classification, layer 3 classification. And you also have a concept of CPE priority, which essentially allows you to tag a particular CPE higher priority than everything else. So imagine that within a particular CPE you have normal or voice high low priority, but across multiple CPEs you may be able to tag particular CPEs serving enterprise customers as higher priority. And all this QoS is happening inside the system with our advanced software. One other simple concept about voice over IP that I think is a differentiation gets a little deeper into the technology, but with voice over IP, allocating bandwidth at the right time when it's needed is the most challenging thing. One of the mechanisms we utilize is the concept of a piggybacking theory, which is where if somebody has VoIP packets and they're doing a poll response, they're able to request additional bandwidth for those voice packets that are coming as piggybacking to that request, as opposed to sending a brand new bandwidth request. CCTV or video surveillance. Once again, we have done enough studies to understand how each of these applications are impacted in a negative way based on whether it's jitter for voice over IP, frame loss for surveillance. So when we look at optimizing our software and solution, we keep those performance metrics in mind. And with that, we built our adaptive modulation to target zero packet loss. So we're taking care of acknowledgments and retries underneath so that a video surveillance system is not presented with frame loss. Objective there, that we will provide you the best-in-class video surveillance solution in this compelling price point product line. There's 3 pictures here, but these pictures actually convey some hardware options that allow you to offer video surveillance at a pretty compelling price point. Top left is your typical scenario where the camera is powered by its own power supply. You could have your own switch, or in that case you can also use the built-in switch that's on the ePMP subscriber module, or CPE. It's a 10/100 switch. It allows you to avoid an additional switch in order to route the camera traffic. The second port of the ePMP CPE also has a 30-volt PoE out. And then last but not least, we have some accessories in development where that 30-volt PoE can be converted to a 48-volt 802.3 AF. Conclusion here on the surveillance system is we're giving you not just a software benefit, but there are some hardware aspects of this that gives you the advantage of deploying a low-cost video surveillance solution. Quick picture of a deployment of Wi-Fi backhaul. Similar concept. There's a Wi-Fi access point down on the pole, ePMP running its proprietary reliable wireless link, and Wi-Fi is providing coverage below. One is in 5 gig, one is in 2.4, another application of using ePMP. IPTV, not a big thing possibly because we have many options for television, but just a quick note that things like multicast, on top of that reliable multicast, where we're converting multicast to unicast for acknowledgments, IGMP snooping, these are some of the features being offered around delivery of IPTV. Important slide, an introduction of the solution overview to understand what are the hardware variants we're offering. Very top left is what you see and what we call the GPS synchronized radio. And when we talk a lot about frequency reuse, this is the unit that can serve as a base station, an access point, and offer that frequency reuse. So this is the key unit. This has a gigabit Ethernet, built-in GPS chip, as well as a antenna connector port and an antenna that comes with a box that you can choose to connect to that port to get GPS synchronization. To the right of that are the variants of our subscriber/CPE. You have your connectorized CPE, where you can add an external antenna. And then the middle one is our integrated module. And then very far to the right is the dish antenna, known as the Force 110. And this Force 110 actually marries a 25 dBi dish with a $99 or a connectorized subscriber module. In the bottom part, you have your sector antenna, and then you also have an offering that is a reflector dish that goes with the alignment arm with the integrated subscriber module, giving you a 6 dBi additional gain. This has been a topic that has come up, a little bit of clarification on what is the Force 110 versus the Force 110 PTP. This slide shows that Force 110 is the marriage of our connectorized unsync radio with a 25 dBi dish, which is the 110, creating this high gain subscriber module that is the Force 110. Key things to note, this is a 10/100, no gigabit, and essentially it utilizes the unsync radio. MSRP at $129 per end. The Force 110 PTP. Force 110 PTP takes the GPS sync AP, in which case the GPS sync mode initially at launch was disabled, but we've actually since then enabled it with a new software. But it has some limitation in terms of how many CPs you can connect to it. But in this case, it's the GPS sync AP with gigabit Ethernet, same Force 110 dish, giving you a Force 110 PTP mode of operation. And the positioning of the Force 110 PTP is very much a backhaul play, low cost, high performing backhaul play, while the regular Force 110 is the high gain CPE play. A little summary on the operational modes at the final stages. You've got your PMP mode, within which you have a GPS sync, where you're going to have a 5 millisecond frame and a TDD concept, or you can have the flexible mode, in which case you're no longer doing GPS sync, but the frame duration is shifting left or right or increasing, decreasing based on downlink, uplink traffic. And then you can also run that mode as a point-to-point, or you can run our ePTP mode, where you're getting the 2 to 3 millisecond latency. The very top of this table is an inter-vendor interoperability mode. It's a bit of a mouthful, but at the end of the day, the idea behind this is that ePMP is a proprietary solution. It is not Wi-Fi. The reason it's and because it's a proprietary solution, we're able to give you functioning GPS sync, thus frequency reuse, and all the other things we talked about. However, we realize that there are other systems out there that are Wi-Fi or can operate in Wi-Fi. We also are able to operate in Wi-Fi mode. So a migration strategy would be for ePMP to operate in Wi-Fi mode and being able to talk to third-party devices or other brands that are also operating in Wi-Fi mode. And I'll have a slide on this in 2 minutes. Going back to tools, or a touch on tools, we talked a lot about the product, highlighting that Cambium as a company, we're very committed to offering a lot of debugging statistics and making things as easy to plan, manage. So therefore, things like link planner, capacity planner, network management server, as well as built-in tools like eDetect, eAlign, automatic channel selection are rich in what they can offer in terms of planning, troubleshooting, and building a network with ePMP. Quick screen capture of the capacity planning tool, which is an Excel spreadsheet that goes through and lets you predict a link quality and capacity. Link planner, many people may be familiar with this, using point-to-point link planning. Now it's offered in point-to-multipoint and specifically ePMP. Allows you to predict link budgets and things like that. Cambium Network Services, management tool, free of charge, download from the website, discover the product, do upgrades, monitor alarms, and last but not least, do device configuration. Few other tools that I won't get into too much, but this is a screen capture of the GUI that shows eDetect, a way to, without interrupting service, take a look at interference at the AP and SM. Not really a spectrum analyzer because it actually gives you MAC addresses of interferers MAC and RSSIs that you're seeing, and a helpful tool when you get that first customer support call. Lots of statistics on retransmissions, packet drops, packet errors. Automatic channel selection, a tool that can be enabled and started at the very beginning, and it will come up and pick the best channel for the radio to operate on. If you don't want to get into a lot of RF planning and frequency reuse, this is a quick and easy way to get the product operational. Migration, touched on it a little bit about the Wi-Fi mode, but being able to configure the SM or CPE in Wi-Fi mode to talk to a third-party Wi-Fi device, or coming in a very near future release, turning the AP into a Wi-Fi access point, being able to talk to a third-party subscriber. And then last but not least, if you want to benefit from the full advantages of an ePMP as a proprietary system, you can forklift and put ePMP in your entire network. Some quick examples of deployments we've done, case studies, some customers, Silo Wireless in Canada, moving away and started to use frequency reuse. And for them, the cost of the product was key. So therefore, getting this high-performing system at this price point was very advantageous. Some quick screen captures on the right side, ePMP. Video surveillance in Chinatown in Seattle, Economic Development Zone. ePMPs were connected up short distances. This is something that's been running for almost 2 years now. We've had no issues, very reliable, and the cameras are working great. Actually, a long-distance link, about 150, 180 megabits, 58-kilometer link, using a third-party dish, 30 dBi dish with an ePMP in the back of the dish. Kayse Wireless in Lake Charles, Louisiana. They've moved over to ePMP after having some struggles with other equipment, and they've been very happy. And they're at 30 customers on one AP. I believe they've actually expanded even further beyond that, but that's what they reported when we first engaged with them. Summary at a high level. A few images here and things, but I will go through the key bullet points. First and foremost, you're getting the industry's only solution at this price point, giving you frequency reuse. I believe running unlicensed 5 gigahertz, we all appreciate the need to save that precious channel that you find. Therefore, having GPS sync and frequency reuse is a huge, huge advantage in this market. Number of CPs to an access point. You will have dense areas to serve, and therefore being able to reliably do that without having to worry about finding a next AP and another channel is key. Best-in-class performance in the presence of interference with all of our MAC layer and scheduling and air fairness. Lots of tools. You have Link Planner and all these other good tools to use. Then you have application-specific tune-up. The Mac and the software, the scheduling, all of that is tuned for different applications. Different modes of operation with flexibility. And then last but not least, Cambium support. which is where you are able to talk to a real person, you are able to get a real response from a real engineer when you have an issue. This, I believe, is one of our strongest differentiation today and will continue to be so as we serve our customer base. And some information on the community forum, which has become a very key source for technical information. I myself monitor that along with other engineers on the team as well as our support personnel. And with that, I will close the presentation and take questions.
Great. Sakid, can you hear me okay? I want to make sure because I think at the top of the hour we had some audio issues. So
yes, I can hear you okay.
So I'm going to do a little bit of what I normally do at the top of the hour, at the bottom of the hour here, and then we're going to get into some of the questions that we have. So we have some very good questions and some interesting dialogue. First off, I want to make sure I introduce the host who has been doing this presentation from Cambium Network. Sakid Ahmed is the Senior Director of Engineering for Cambium. He knows a lot. He's been with this business, in this business nearly 20 years, spent 3 years with Cambium since the very beginning and 14 years before that with Motorola. So if you have questions, he's a great person to get an answer from. And what he just said a few moments ago is a critical point. Cambium does stand behind their products, and they do have a good support mechanism both through their engineers, for which you can get questions answered, product support, as well as the community network forum, which is a great place to get other answers. I wanted to tell you who we are in case you're interested in buying any of this equipment. You are able to do so freely and get answers as well through Streakwave Wireless. Streakwave is a value-added distributor of wireless equipment, including broadband equipment, and including the entire Cambium line. If you see anything here that interests you and you have questions, you can always call us on the 800 number 888-604-5234, or as always, come to streakwave.com. Those of you who attend our webinars with any regularity know that we get a lot of questions. And we try and be very frank and upfront with our manufacturers, ask them some questions that go into all kinds of detail. So we're going to get to that right now, talk about these products in a little bit greater depth. But again, if you have any questions, you can contact Streakwave, or we can put you in touch directly with Cambium where it makes sense. So first off, let's talk a little bit about getting these products into the field. If I'm interested in trying out ePMP, and it's the first time I'm using this product, I've been in the industry for a while, perhaps I'm a WISP that provides services, how easy is it once I put out a few APs and set up a tower and go on out into the field with my equipment, how easy is it to configure this equipment? Let's talk a little bit about that.
Sure. So when we designed the product, that was one of the key things that we kept in mind, that ease of configuration is very important. So giving you a few examples, we are giving you different modes of operation. So you've got your TDD mode of operation where you're trying to do frequency reuse, etc. However, if you wanted to just say, I want to put up an AP, let it just do its thing, and I'll just take a subscriber, and I just want to bring up a link, we give you that option as well. You enable something like automatic channel selection at the AP reboots, it comes up, it scans the entire band, picks the best channel from an interference perspective. You take the CP out to a field, a mile, 2 miles, every channel is selected, CP goes through the scanning procedure and picks the channel that the AP is operating on and it connects. That's one way to get a link up very quickly. Other than that, if you log into the GUI, at the end of the day, configuration, radio icon, pretty much 3 or 4 parameters. Country code actually won't even matter for North America, but power, frequency, setting those up is pretty much all you need to do. One of the key things I want to highlight in responding to this question is the concept of transmit receive level, which represents the transmit power control parameter that we talked about. This is what tells the subscriber / CPE what its target power should be. It's always important to pay attention to that parameter because by default it's set to next 60. When you're first deploying some systems, you want to take a look at that parameter and play with that and say, I need my subscriber to shoot a little more power because I'm just trying to get through this interference. But fundamentally, the answer to that question is the standard transmit power, receive level, frequency, maybe authentication. It's all the standard stuff that you can configure through the GUI or SNMP and get a link up and running.
And I can do that remotely, or I have to do that when I deploy it? Can I change that power?
You can do that remotely as well. If you happen to have the link up and the subscribers register, you can go in, log in, and remotely change it. As I mentioned, the CNS, Cambium Network Services tool server, can also be used to push like a template or a configuration change, all via SNMP.
Perfect. And so once it's been configured and I have it where I want it, what of the tools, you mentioned a number of tools, what of the tools do I use to monitor the system? And from that monitoring, am I able to make adjustments across the entire network, or do I have to do it one-on-one? How do I approach it when I'm monitoring it once the network's up?
Right. Every parameter that's displayed in the user interface is available via SNMP, and you can download our MID. So while I'm talking about CNS, our tool, you can use third-party tools to do monitoring of the system. So you are looking at statistics coming from the radio, everything from what modulation is it spending more time on, air capacity, air link, is it 100% or is it always at 50%? Am I seeing a lot of retransmissions? Am I seeing a lot of packet drops? So these are numerous statistics that are coming to you and are available in the user interface, or you're polling them via SNMP. So now you know that in your entire system, you're able to monitor the whole system and then look at for problematic systems within the network and go solve those specifically. So I'm giving you all the statistics. I'm giving them you via SNMP. I'm giving them to you via our own network management tool. So these avenues are present to you in order to troubleshoot and monitor the network.
Great. So I have the ability to go in and look at even minute details about the network, monitor it, and change it on the fly from various locations.
That's correct.
That's correct. Okay. So let's turn to some of the unique aspects of the ePMP system. Specifically, let's start with GPS. So first off, tell people, I know we're talking about a lot of technical information about specifics about things like latency and distance and timing and so forth, but explain to them what GPS does for them. We're talking about noise mitigation here within an internal network. How does GPS function, and then how does it function within the ePMP system? What makes it special, and how do I use it?
Right. So fundamentally, let's step away from all the details and think about one thing only, which is what benefit is it giving me? Why do I even care about GPS sync, or what does that mean to me? Fundamentally, what I've repeated in this seminar and in many other sessions is that we are in 5 gigahertz, 2.4. Interference is the name of the game. But the source of interference, you have external interference, and most importantly, you have self-interference. External interference you don't control. Self-interference you should be able to control. And we don't have a lot of products out there, in fact none at this price range, where that self-interference component is controllable. So we'll stop right there and say that what ePMP is giving you is a tool and a product that lets you solve your self-interference problem. And now, if you've solved your self-interference problem, you can ask one layer additional question: what is the plain English benefit? And my plain English description of that benefit is that before, when you were hunting and pecking for a clean channel and trying to put up extra hardware to protect your APs, you're trying to find more guard band, I am letting you use ePMP and use the same channel in, let's say, a back-to-back access point. The concept of frequency reuse. So I'm giving you a platform that helps you with your self-interference. The result of that is you are able to do frequency reuse. And that is the benefit, and that's probably the most important message to take away from this entire session. You are able to do frequency reuse. We talk GPS sync, very clear message. GPS sync is the how. Or actually, one of the hows. Once again, repeat it. Frequency reuse is the benefit. GPS sync is the how. We use GPS Sync as a reference clock. We built this entire software stack, this scheduler, the Mac, all of that plays together in a synchronized fashion to give you that frequency reusability. I hope that helps clarify this a little bit, Richard.
It does, but let's hone in a little closer. So one of the uses, or one of the predominant uses for having GPS sync on your radio is so that when you talk about back-to-back, I can put multiple radios on the same tower or the same deployment site, maybe 4 of them facing 90 degrees in each direction, and cut down or do away with the interference between the radios themselves that are back-to-back. Is that what you mean by that?
That's exactly it. Yes, that's correct. And you're using the same frequency.
Do I need to buy additional devices or shields or anything else, or does this stop the need for having to do that?
This stops the need for having to do that.
And how many radios could I put up on a tower at any given time using this technology?
Right. So 4 is what we recommend. The 4 90-degree sectors will give you the most optimal deployment and frequency reuse.
And by doing that, I would obviously cover 360 degrees on
That's correct.
Tower.
That's correct.
Let's switch to another topic. Let's talk about power for a minute. First off, what is the power for operating these? And secondly, you mentioned that there's a port on there for running other things. What is that power, and what type of power does it provide as a PoE? Tell me a little bit about the ports.
Right. So before we talk about the port, real quickly, the GPS Sync access points, they are 802.3 AF capable, so they can be powered by an 802.3 AF switch, which is nice. You don't have to buy a separate power and separate switch. You can use the switch to power the access points. The brick or the power supply that comes with it is a 15-watt power supply, so at any given time it's not going to consume any more than that. The subscriber modules are 30 volts, again 15-watt bricks. And then to touch on the second port real quick, Richard, the second port of the subscriber modules are configured to have a switching functionality as well as have a 30-volt power over Ethernet output from them.
So with 30 volts and a switching capability, I can hook a camera system through that if I want to.
That's correct.
To do the security and surveillance needs, have a remote monitoring location if I want. That gives me enough power, and it's switchable, right?
That's correct. That's exactly correct. So it does open up the door to applications and doing these applications without additional hardware. We're giving you a much more flexibility and also allowing you to reduce your CapEx costs as you deploy in other applications.
Now let's switch over a little bit to the QoS functionality of ePMP. You mentioned VoIP. We've talked about security and surveillance cameras. Obviously, there's data services. Talk a little bit about how QoS operates, and what can I choose which thing I want to favor? If I want to favor voice over video or data over all of them, how do I make that decision? And how does it affect the performance of the device?
Sure. Good question. So first answer is absolutely everything is configurable. What we have are your layer 2, layer 3 classification rules represented by, let's say, VLAN ID or a MAC address or an IP address. So if you happen to have a PBX up on the network somewhere doing voice over IP, you want to prioritize all that traffic, then you can say, hey, default prioritization is enabled, and any packet tagged with, let's say, a particular DHCP or a class of service value will now be prioritized within the system. Similar with, I've got an IP camera with IP address XYZ. I want all packet coming from IP camera XYZ to be on my high priority QoS channel. So you have all this configuration ability. All you need to do is go in the configuration QoS tab. It's pretty simple. There's little pop-up icons that will explain further with text what they mean, but it's pretty easy to configure. And once you configure this, we've designed the system in a manner that having quality of service does not have any impact to the performance of the system.
So it's just it's a function. It's not going to affect whether or not the system can handle the capacity. It's more of a function of choosing which has priority.
Exactly. Exactly. That is correct. That is correct.
So I flip around a little bit on topics. We talked about GPS, and we got a couple of questions which I think I want to nail in a little bit more about why we use GPS. GPS is used mostly by APs to time against each other so we don't have self-interference between radios. I got a couple of questions about whether or not I needed the GPS on the CPE unit, and is there any reason for GPS on CPE?
Absolutely not. There is no reason for GPS on the CPE. The access point is in charge. As long as they are synchronized with each other, they tell every CPE what to do when. Therefore, there is no reason for synchronization on the CPEs. Your network is synchronized at the access point level.
So let's turn that back to the other side. So once we've got our network up, we've got a tower or several towers with multiple ePMP access points on them, activated with GPS so that they're not interfering with each other. So we've taken care of the internal or between our own radios interference issue, and we just clarified that that doesn't involve the CPEs. Let's talk about what we do for regular interference mitigation. Now this is in a standard 2.4 or 5 gigahertz configuration. So there is going to be noise, and pretty much anywhere you go, someone's using one of those frequencies. What are some of the things that they can do to mitigate those? Those are not GPS functions. And does the equipment have noise mitigation considerations for it? And how much does it affect the system outside of what it would affect any system?
Right. So the fundamental difference here, the fundamental thing that we do is, first and foremost, when there's external interference, the nature of that interference is that it's not consistent. Typically, any product out there that is causing you problems or interfering with you, it follows the transmission and receive cycles, i.e. if somebody's surfing the web, they're looking at some video, it's not a constant stream of energy impacting you, typically. It goes in and out as things happen. How a wireless system reacts to that, how a wireless system adapts to that is the differentiation. So in my presentation, I spoke about the concept of the adaptive modulation. This is what tells the radio, are you operating at 64 QAM, i.e. MCS 15, or are you operating in MCS 12 or 11? When interference shows up, downlink or uplink, am I going down in this modulation and just sitting there? Interference is come and gone and I don't go back up? Or how well do I adapt to that? How well do I adapt to it while keeping my throughput at the most optimal condition? That's where the differentiation lies. And what ePMP does is it has a very, very fine-tuned adaptive modulation that can change gears very quickly, very frequently, while keeping that throughput high. We obviously have a ARQ, an automatic repeat request mechanism that runs underneath. So if there are interference caused packet loss, we are recovering, retransmitting. And we're doing all of this underneath the layer to present you a system that will perform better in the presence of outside interference.
Okay, great. Now we have 4 minutes left. I want to tell the audience a couple of things on housekeeping, and then I want to turn to the future a little bit. First off, on housekeeping, the most commonly asked question I'm asked during any webinar that Streakwave does is, boy, there was a lot of information in that webinar. I sure wish I could see either the slides or the presentation again, or my engineer would like to see this. How do I show it to them? We will be making this presentation available on demand in 2 locations. Give us about 2 days. It usually takes us a little less than that, but we asked for 2 days. And it will be available on Streakwave's YouTube channel at youtube.com/Streakwave, or on the landing page. We call it the landing page for Cambium. You just go to streakwave.com, pick up the manufacturer Cambium Networks, and you will find the webinar available for on-demand watching right there, right from the website. So you can pick and choose which slides you want to look at. You can listen to any portion of it that you want to, again, and there is no cost. So use that and our other resources as education and background whenever you like. I would instruct you that we also have a learning center on that website, so if there's topics such as noise mitigation, point-to-point deployments, questions about backhaul, all kinds of things like that, we have videos available for those subjects. Again, Streakwave is available at streakwave.com, and if you have questions about these things, you can call us at 888-604-5234. Sakid, so let's turn to the obvious next thing. And by the way, if your question hasn't been answered and you've put a question into us, or you have one and you want to put it in now, we'll be glad to get back with you offline. We're coming up on the hour, and I do like to respect that hour so that our webinars go pretty close to when they're supposed to be. But let's turn to the last 3 minutes and talk about roadmap. What can we expect from Cambium? This has been a very exciting webinar so far, telling us about all kinds of interesting stuff and sort of cutting-edge stuff that's coming out of Cambium and the ePMP line. What can we expect moving forward?
Very good question, Richard. So the word excitement is probably the best way to describe how we're representing the ePMP product line. So everything we talked about today is what you have in the marketplace. And obviously there's been great innovation around it. But beyond that, as we move ahead, we have quite a bit of research and development, a lot of smart people, a lot of money being spent in evolving the roadmap, evolving the platform. Very quickly, on the software front, we've been engaged a lot with our customer base. Your requests come in, you need a minor GUI change, you need a small networking feature, we respond to it. So we had approximately 14 software releases last year where we did a lot of things and fixed a lot of things and added a lot of features. This year we have much less, but we continue to add new features. Some things that are coming down the pipeline that are important for you is things like the concept of a 2.5 millisecond frame. I talked about TDD, 5 millisecond. The idea behind this is as you scale up the system, we are trying to bring your latency down even more. So there's features coming around that. From a hardware perspective, we will be having new subscriber modules, new integrated dishes that will be better performing and higher gain coming later this year. It's a little later in this year, so therefore we haven't quite released them, but there's good hardware platforms in development. A few other key exciting things. On the access point side, we're also looking at advanced concepts around beam steering and 802.11 AC Wave 2, things like that, where I can give you more throughput in the environment that you're in. And a lot of intelligence, a lot of research is going into that. So needless to say, both from a software perspective, you'll continue to see new software releases with advanced features, small features and big features. And on the hardware front, you'll see new products out on the CPE side of the house, as well as some pretty nifty features that give you higher performance and very high noise on the base station side.
Excellent. Sounds like there's a lot to look forward to, and if you haven't tried these products, I would highly suggest you do. They're very affordable. This is a great set of features in a very affordable price point. I want to thank Sakid Ahmed, the Senior Director of Engineering for Cambium Networks, and I'd like to thank our partners, Cambium Networks, for being here today. As always, they are available to answer questions, as are we. If you're working on a project near and far, we know some of you are from many nations around the world, please feel free to contact us through any method that works for you, and we'll be glad to get back with you. Again, my name is Richard Bernhardt. I'm the Senior Director of Marketing Communications for Streakwave Wireless, and Sakid Ahmed has been our guest for today from Cambium Networks. This has been the ePMP North American line, and we want to thank you for attending. Have a great day, and we look forward to having you at our next webinar sessions. Take care now.